Okay, this semester, uh, this is a new course, so I haven't really made up the complete uh, write-up in like MS Word. So some area I prepared for PPT, or some area I prepared for by the Word. But at least more than half of the time, I'm gonna write on the whiteboard. So then I'll try to give you the copy of my notes. So that's the way I like to try this semester. Okay, and most of you know my name, right? I spent already 2 years here, so so this is my name. My office, the one sheet I gave you contains all the information. My office is in the third floor and room 106. And whenever I teach, you have priority. You do not need to make an appointment to see me. If you like to see me, just knock the door and just to come in. That's the policy I do. Students has a top priority. That's the way I do that. And in my experience, you usually don't stop over to my office and talk. I really like to talk or chat. So whatever the problem you have, I'll try to solve the problem, provide the solutions for the given problems. Okay. And I came here as a visiting professor, or I call WCU invited professor. We have, as you might know, the government program, 5-year government program. So I joined 2 years ago. So after program started, so I'll stay here until around the end of 2013. And my area of specialty is underwater shock. What happened? There is a shock event in the water. So it's rather a unique situations. What happened there if there is underwater explosions? It's all transient phenomena, and not the steady state situation. Steady state situation is like you can count as a part of the transient phenomena, but that's where I have been working for last 30 years in Naval Postgraduate School. You heard about Naval Postgraduate School? It's U.S. I'm just introducing myself a little bit. As I see you, I know Yun Seok very well. I know Yonghyun, my student. Higyu was with me already 2 years. So he's working for a doctoral degree. Kyung-seok is my student. But Mr. An Jung-gun, I know him fairly well. But rest I saw on the hallways. Oh, you're so beautiful. I always, whenever I say, oh, she's here. So it's very nice. Okay, U.S. Naval Postgraduate School. This is a graduate school in Monterey, California. Monterey is really beautiful, beautiful town in the west coast in California. I worked there about 30 years. Then I retired uh, 2 years ago. Then there's opportunities, so I came out here. So I stay out there in the state total about 44 years. So it's longer than half of my life I spent in the state. And but I was born in Korea and went through the schools all the way through Seoul National University. Then joined the army as PFC. He's a Navy lieutenant right now, in Korean Navy lieutenant. I was a private first class. I think you do like this. Private first class, serving in the really front line for 18 months. But it was very painful situations. early 1960s. It wasn't easy. Like a day looks longer than a year or 1,000 years. Survivability is the most important out there. Survivability is the kind of the topics in this class. Survival, so failure, probability of the failure, probability of the survival, complement each other. Total is one, vice versa. That's what we're going to talk this time. So I really enjoy to talk and teach or share the experience with the students. But my topics is somewhat narrow, explosion, very narrow field. So last year or March last year, 2010, when China naval ship was attacked, there was really nobody around in Korea who can claim the expert in underwater shock problem, underwater explosion problem, except one person, Dr. Jung-hoon from the Korean Institute of Machinery and Matters. I kind of act as a mentor to him for the last 15 years. I came out here every other year, and I really train him in underwater explosion because Korean Navy need that technology to improve the survivability of the ship, the vice versa. So anyway, the structure reliability, you know, I work when I really was in graduate school. This is a part of the PhD dissertation, and I haven't really going into deeper since then. Then as I look through this whole 3 months, I spend nothing but the structure reliability. I'm confessing you to really update all the knowledge in this area since I learned long time ago. And it is fascinating. And after the summer, I feel especially ocean systems engineering students should learn this subject, because not only popularity at this time, but it's a matter of the failure or survival. So that important. So in Professor Chang, Taejun Chang's research area, I think some of you, how many working with Professor Chang's for thesis topics? You see? So he has been teaching already the reliability. But I could say he is expert in processing reliability. I'm doing structure reliability. So it's kind of the complement each other. So to be a complete. So if I say, if I say this is the whole thing, I don't know whether it's 1/3, half, 2/3, but I could say this is a processing reliability, and I could say structure reliability. So how to build the safe structure system. That doesn't mean that in this class, if you ask me, do I have to know everything on the structure mechanics? No. But as we need, I'll show you the area. So that's what I want to do. You can be the expert at everything in any particular area. You can pick it up and learn and study, and that's the way to go. Especially ocean systems engineering. You know, some of you major maybe civil engineering, or mechanical engineering, or electrical engineering, chemistry. Anybody majoring chemistry? Or chemical engineering? See, chemical engineering. Have you ever learned about structure mechanics? A little bit. See? So this is ocean engineering department as I look at it. It's a system engineering, of course, dealing with the whole system. And when you say learning the system, let me tell you some experience. When I work at the Naval Postgraduate School, I belong to mechanical and aerospace engineering. Then we have a system engineering department established about 6 or 7 years ago. Then there is no tenure professor there, so school asked me to serve as a joint professor. So then I tried to help them up. Then I really, as I myself was exposed to system engineering, at the beginning, I was in a little bit frustration mode. The reason I'm telling you this is really some of my experience, which was sort of a frustration, give me the frustrations and all that. System engineering. And I asked the professor there, what do you teach? What area do you teach? System-wise, it could have connected to chemical engineering, civil engineering, mechanical engineering, you name it. It's just connected to all over. So in Europe, I found it's kind of difficult to really say teach the system engineering. Of course, in just overall matters could teach. In Europe, I found out they don't have really system engineering department in the university to teach the system engineering, but they build the system engineering department in the given industrial company. Some could be a chemical company. Then they have a wonderful system engineering department to deal with the chemicals. So in the particular areas, they develop the system engineering. That's what I found out in Europe. So in US, we don't have many system engineering department in the university. So if you go out saying, I want to pursue the doctoral degree in system engineering, you might face a little bit frustration or a little bit problem. So when you identify the particular area, like mechanical or chemical, industrial, then it's very easy to define the field that you want to really go in. So in this, you took the Professor Chang's course already, did you? The reliability area. And here in this semester, I want to really like to teach you the foundation, then you can really build on it, okay? Because graduate school, if I say A, then you should be able to write B, C, D, E, vice versa. So that's the way I think we should grow. In Naval Postgraduate School was somewhat different in teaching because all the naval officer, military officer, they're all going out to the field for about 5 to 10 years. Then they're all coming back for advanced degree program. It's a master's and doctoral degree, mostly master's degree. So we have to retrain most of the students starting from the junior, senior level undergraduate. But here, as I see, mostly you are coming after bachelor's degree, you come right in, right? So, which makes very nicer. However, it's not all ocean systems engineering major in undergraduates, right? There is no ocean systems engineering in undergraduate. So you have to really build with the faculty, but it's not going to be spoon-fed. This school is not spoon-fed approach to students. And this class, I really like to try more. Provide the basis, then you build the system with the good foundations, okay? You have my email address, my telephone number, but the number here is my office number. I don't mind if you I forgot my the handphone number. Because I usually don't punch my handphone number. 6, I think. I'll tell you later. Sorry. Do you remember the handphone number? Let's try this. This may work. Higyo, is it correct? See, he's looking. I think this is right. I hope. Still looking? Correct? Okay. I don't mind if you call to a handphone. In US, we never say handphone. What they say is cell phone. I don't know what makes cell. This is my cell phone. Okay. And the textbook wise, I'm gonna just I extract out what I like to teach. Then I don't demand you to buy the textbook, which is not that cheap either. This is something like this is $126, and another book is $132. Another book is $54, but it's not the textbook. I just brought the reference books. I said here the textbook structure, reliability-based structure design. But what I'm going to do, I bought the two sets for you. Then I'm going to leave it to Higyu. You know Higyu, he's my teaching assistant. Stand up. You know Higyu? He's riding motorcycle. Be careful. He's the youngest member in my lab. Sit down. Very nice fellow. He took all the courses. He didn't take this course because this is the first time to offer. And Higyu is going to really do his best to assist me. And I'm going to leave this three set. First, in the write-up, I said the textbook is this book written by three authors. One of the authors happened to be Korean, Choi, but I haven't met him. So this is kind of the new book published this year. But as during the summer, as I look through, he skips quite a bit. So I want you to concentrate to my note, okay, and my handout. Then it's gonna be better. But you can use as a reference book. I'm gonna buy because we have more students. I'm gonna buy a couple more sets. So if I leave, I have a two set. I'm gonna leave this today to Higyu. Then I'm gonna order two more set or three more set. Then 5 sets should be good enough. Then you can share, or you can make a copy for some area, things like that. And another very interesting book is called The Safety Factors and Reliability. When you usually, anybody has been working on the design office, like a building design or any sort of the structure design. If you work in such a company, they always use a safety factor to define the design load. So then question is where they get the safety factor. then the person would say, oh, it's in the code, design code. Where the design code get that safety factor? Don't know. Some people call that factor as a fuzzy factor. So safety factor is the factor of boosting up the actual load to anticipate some heavy loading, something like that. But anyway, this book is written by Isaac Elishikov. Is a good friend of mine. He's a professor in Florida area. And this is very good book, very easy to read. I'm gonna cover the few chapters from this book. So you can look at it. And this book is by Molchers. I never met him. But as I look through a few books, this book, Structure, Reliability, Analysis, and Predictions book, seems to be good. So I'm picking some area, then I deliver the lecture to you. But this is rather pretty deep. See, it has been around for some years. So this is another book. And if you look at the reference book there, looks like, gosh, so many reference books. I hate it. Yes, I hate it. I like to have, whenever I read a book, I like to have a very thin book. Any fiction book, I like to have a very thin fiction book or non-fiction book. Then I can start to read and finish fast. But if you look at something like a reference 3, I have it, but you don't really need. When I used to give you lecture in some area. And the reference book 4, reference book 5, I'm going to give you the electronic file. Then you can use that in the semester, and very nice book. Risk and Safety in Civil Engineering. Professor Faber, he's European. He's in Denmark. Oh, he was in Switzerland, then moved to Denmark. Originally, he's from Denmark. So this covers a wide range of reliability, risk and safety. Maybe Professor Chang may cover not this book, some of the area in this book. And reference 5, probabilistic engineering design, chapter 7. He's writing a book. I talked to him by phone, and he is the best to explain the solution technique for structure reliability. It's amazingly easy to understand, and I'm going to use this chapter 7 when you get to learn the solution technique, okay? And as I mentioned a couple of weeks ago in the course introduction, midterm exam is 30%, final exam 30%, bi-weekly project 30%, homework 10%. But if you just follow the lectures and do what I ask you to do, that's all you need. That's all you need. So the 30%, 30%, 30%, 10%. Sometimes I gave a no exam in the past, but I should give exam. Midterm exam, I think some of you like Yunseok knows the way I handle. It's easy, right? Really, I had a complaint from students. Professor Shin, your lecture is so easy. I want to have a more hard homework problem than I can spend until 5 o'clock in the morning, like a Professor Park. I'm just good friend. I know Professor Park for like 35 years each other. But each person has a different philosophy. My philosophy is not that. Understanding, especially engineering. I am not the theoretician in engineering. Engineering is always comes with the good application. Where are you going to use it? If no application in engineering, then what's the purpose? So that's what Professor Chang is doing. It really. He has a objective. He has a clear goal, clear target. That's what I like it. Clear target. No target just goes around in the big ocean. You got lost. What's the purpose? So that's what I want to do. So, and 16 weeks, how we're going to spend the 16 weeks. Uh, first one is, first, understanding the real world problem. First understand, before you learn the math, understand the physics first. This is a physics first. Physics first. Physics phenomena first. Okay, structure reliability. Where is the name list? I have to start to memorize your name. You have no problem to understand the Korean English? No problem? When you hear about the structure reliability, what came to your mind? I could say, oh, Professor Chang said, go take that course. Take that course. Help Professor Shin. He has only 3 students. I hope that's not the reason. What was the fact it come to your heart? Structure, reliability, some curiosity, isn't it? Some curiosity. What is it? In addition to processing kind of reliability, time-dependent reliability, time-independent reliability. What's the design goal for reliability? Where can I apply? Plant design, how? So, the real world, there is no such a loading. Let's say loading. Even chemical engineering, I think in the sophomore you learn maybe basic mechanics. Sophomore, you look back your textbook, you might have, oh, here is the strength of material. Right? So loading. Or as I introduced in the seminar room a couple of weeks ago, strengths. Okay, strengths. What would be the strength of this column? When I press it or when I kick it, is it gonna break by what loading? Loading. When you design the structure, it's all deterministic. In other words, when you design the building, oh, okay, loading wise in the office, it should be 30 pound per square inches. If you convert into megapascal, what is it? I use all the time the English unit. 1 megapascal is about 145 psi that you can convert it. So usually about 30 psi. What does it mean? In the floor, the people are moving around. There's a moving load in addition to the static loading, the tables, desk, files, and all bunch of. In other words, it's changing, keep changing. And strength-wise, when you just get the samples of the steel came out from the steel mill, then measured by tension testing, the yield stress could be maybe 36 kpsi, 36,000 pound per square inches is what it can take. Is it really true? Some specimen is not 36 kpsi. Some are 40 kpsi. Some are 60 kpsi. Some are much lower, like 30 or 20 or 10 kpsi. That's what the real world is exposed to you. Nothing is fixed. Nothing is constant. Nothing is deterministic. Then you have to multiply so-called safety factor. Because to cover the uncertainty, I have to boost up. How much to boost up? That has to be the probability base. To understand the real world problem, then you have to learn the probability. So this graduate school, in your curriculum, every one of you have to take the probability course, right? You might take that course already. How many took the probability course? Raise your hand. You have to take that course to graduate. And this school is very generous, just to demand one probability course to really expose you the real world problem. But probability, I suggest to you to take that course as early as possible. Then that will help you. I'm teaching usually spring, I'm teaching random vibration class, which is different from classical vibration theory, which has mixed with all the probability theory. But not the whole probability theory, it's just a theory that you need to do the random phenomena. So the first one is learn the probability theory. Probability and statistics is all the same. So I'm gonna show you the probability things that you need to understand the reliability, okay? So I'm gonna really pick it up all that, then I'll show you. Rather than you go study probability, but eventually you have to study probability well. It's a tool for the forecasting. And in the stock market, they use all this probability theory to capture the statistics. What's the chance to win? That doesn't mean that you will surely win. No. What's the probability of survivor? Is it 10% the probability of the win, or 20% probability of the win? Is all that is there, which coming from the probability. So I'm going to talk about this for some time at the beginning, and second, I want to make the objective very clear. I'm going to give you the formulation to solve the problem. So structure reliability problem. Then formulation, we're going to do the formulation to solve the reliability problem. To solve the reliability problem, what should I do? So structure reliability problem formulation. Once we do the formulation, then one way or another we have to solve the problem using the formulation, mathematical formulation. Then your goal has been done. Then you have to apply to the area that you want to do. Formulation, you know, to get the complete formulation, it takes a time, it takes efforts and all that. And in this formulation, I'm going to do first order reliability problem, reliability method. First order. So this first order, I'm gonna rather do the complete formulation. Then you can really see in and out. Okay. Then you will do some good size project. Then you can really write the code. You can use a MATLAB. Here, KAIST, we have all the MATLAB is free. You can just get the CD and download. I think most of you know, so maybe all of you know MATLAB, right? You are using it. Yes or no? Yes? Yes. So anyway, for new students, there are enough informations in the internet and everywhere. And I don't just demand the MATLAB, or they have all different kind of the tool nowadays. This morning I got the email from Mathematica. They're willing to come give a free seminar. Then you can use Mathematica. That was very popular some years ago. First order the reliability method, and next one is higher order. Second order reliability method. But this formulation I'm going to do complete. This formulation I'm going to cover pretty good, but more complex to getting into phase, because we have to deal with the multi-dimensional space. We can understand up to the three-dimensional. Space is all three-dimensional. It can grow in the reliability problem for 100-dimensional. Then difficult to visualize. And then very practical tool, Monte Carlo. Simulation approach. You heard about the Monte Carlo simulation? Anybody using Monte Carlo? This is very popular. This Monte Carlo simulation started from the Monte Carlo. What they do there? Casino, gambling, chances to win. So that's where it begins, Monte Carlo. What's the chance to win? You know, that's the gambler, that's their best and most interest on that. And after that, what's the third step would be? One part, second part. Third part is, now we have to solve this problem, right? We got the whole complete formulation, mathematical formulation, then we have to solve. So we have to learn the solution technique. This is connected right here. This is really solution technique. This is a formulation related to this. And also then we have to solve this, the formulation, mathematical formulation. So we have to go solve the problem. Okay. So this four, I need your help also. I don't want to really, this semester, I want to work together rather than using the mode, hey, you teacher, you stand there, you show me. I'll just sit there, then I'll pick it up. I'll just open my mouth, then you just drop the things in my mouth, then I'll pick it up, which is not good. Sometimes the stuff I'm dropping is not tasteful and hard to swallow. So number 4 is going to be the multiple project. I'm going to assign the project to exercise the stuff I am teaching you. Then develop the project. Then really solve the project. To apply all this. That's a bi-weekly project is what I want to do. And I like to make a group. So we have 11 students here. 11 students, so maybe just 2, you know, 2 people can be one team. 3 person in one team, which is not very good. Why? Third person is already sit back, relax, have a beer. So 2 looks good, okay? So 2, then one team has to be 3 because we have 11. But who knows? Some of you may drop saying, "Hey, that's not the area I want. I have to let some of you go, but I hope not." So it's worth to explore. It's explore. So this project right now is a 30%, 30, 30, 10. But that's the things but I could wait more in the project and, discount, get the lower point for exam. So I want to play flexible. Then don't say, whenever I teach machine design class in the state, and one student raise your hand and say, "Professor, yes, the way you talk is just you do as you like it. There's no rules, and design is personal. Design is personal, very personal. Some people like Volkswagen. Some people like a cruise. It may be old. It's all different. But I see the goal to achieve is most important. The approach, I want to be the clear path rather than rough path to go. So it's a project. I'm talking about 16 divided by, usually 14 divided by 2, about 6, 7 projects. And some project may be really, really interesting. Okay, that's the way I want to do. Time is almost up. Any question? This is all I'm going to say for the time being. Any question? First class is, we discuss it. Any question? No questions? Yesui, any question? Jungani, any question?
Actually, I'm wondering one thing. I have another test of deep field of relativity.
Oh, this is, how did you get this?
For me, I got the electronic part.
How did you get the electronic?
On the website.
On the website you have found this? Wow. In the website. Well, you heard Mr. An said he has electronic file. It's an amazing world, Anyway, this is the book stuff. I have 2 sets. As I mentioned, I'll leave it to Higyo. Then I'm going to buy 2 to 3 more sets. I think that's enough. Then he has electronic file for 1 book. So I cannot comment on that. Okay, I'll see you Monday. Okay? Same time.